Welcome back, folks. Till now, we have seen linear measurement and angular measurement instruments and what are the type of the instruments and how to measure the roughness, waviness and finish of the surface texture. So now we are going to see coordinate measuring machines. So where they will be used and what are the importance of these instruments or the machines and where generally they will be used and why they are different from previous instruments what we have discussed in chapter 4 or unit 4 and unit 3. So generally we have discussed micrometer, vernier caliper, stylus measurements and different types of instruments used for linear measurements and angular measurements, but still there are important machines which doesn't come under linear or angular measurements. So we have to give a separate name for them, right? So these coordinate measuring machines are nowadays an integral part of the modern factory, and also the machine tools are the drivers of the modern factory systems, right? So if my machine tool is more precise and accurate, then the product coming out from that will be more precise and accurate, or else there will be so many imperfections happening with machining, then the product coming out from that will also having the imperfectness continuing with that product. Now coming to this coordinate measuring machine. Generally measuring machine of single axis corresponds to the linear measurement, right? So now if I just want to measure linearly but in different directions, considering a coordinate system, a coordinate system will be having three axes x, y, z. So I just want to measure in three directions, either x, y, z. This single axis measuring instrument can't do the job what I need, so I should have another machine or an instrument which can measure in all the three directions, which is nothing but the coordinate measuring machine. Such a machine is popularly abbreviated as CMM. So this CMM enables the location of point coordinates in a three-dimensional space. So this CMM, initially it is started in 1960s in United States, then they have improved its electronics and again they have introduced the CMM freshly in 1980, in which that improvement is goes on continuing, and now it is fully advanced CMM came into factories, outlets where you can measure orthogonally or in any axis. You can measure either positive x-axis, positive y, or in the negative z-axis, positive z-axis, whatever way you want you can measure use the factor or the surface texture in any direction. And one more thing is this CMM, you can connect directly to the system and you can generate a 3D object where the path has been followed, and you can further whatever generated 3D object is there, you can further analyze for a mathematical analysis and you can find out the results for the surface texture. Complex objects can be dimensionally evaluated with precision and speed. Obviously, the primary application of CMM is for inspection. Generally, in factories, the CMM is used for the inspection of the products. Since its functions are driven by an onboard computer, it can easily be integrated into computer integrated manufacturing environment. So in CIM, we can use the CMM for integration for the inspection. So coming to the advantages, or we can call it as what are the different types of CMM available in the market, or why we are going for this CMM we can explain with this slide. Like we are having an multiple features. So if the CMM is having more features, then the cost of the CMM will be, obviously it will be high. Like flexibility. It offers flexibility in measurement without the necessity to use accessories such as jigs and fixtures. Obviously, single point measurement or machines which are operated with single axis, they will be having an jigs and fixtures, which again increases the maintainability, machinability, everything. So if you just go with an CMM, it is having a flexibility that we need not to have the jigs and fixtures. I'll be explaining in the next slides how it is avoided. Automated inspection. Whenever inspection needs to be carried out in a fully automated environment, CMM can meet the requirement quite easily. That's what I have told you. Because of the improvement in the electronics, already the modulated wave, carrier wave and analyzing the waves whatever coming from the roughness of the surface texture, and then demodulating and magnifying and comparing, we will be getting the best result. So this the entire process is automated, which makes the factory having a lesser cost per unit and high unit cost. For example, if you are manufacturing one steel pen, during the first manufacturing unit you have found out some defect in it, so you have to scrap it. Again in the second unit, again you had some problem and you just need to scrap it again. So the reworking for the third time you are reworking, and at the third time you are getting a success. Because of this scrapping, you are going to increase the unit cost of that pen, because the manufacturing process done for 3 times. But if you just go for CMM, all the analysis can be done in the simulation, which can be used using some computers or some softwares. Then you can finally go for the physical product, which will reduces a huge manufacturing cost, right? These are the advantages. Coming to the structure of the CMM, the basic version of CMM has a 3 axis along 3 mutually perpendicular directions. So whatever work we have to do, it can be done in a cuboidal way. Like whatever the measuring probe can reach any point in a cube. If we just consider a cube, which is a 3-dimensional one, which is having an 8 faces, so my measuring probe can go anywhere in that cube. Like it can roam anywhere in the 3 axes. A carriage is provided for each axis, which is driven by a separate motor, while the straight line motion of the second axis is guided by the first axis. The third axis in turn is guided by the second axis. What is this carriage is like a reference line. If we just consider a rail, the train, how it is just going over the two parallel lines, in a similar way for every carriage one motor is provided, okay, and the motion of the second direction is guided by the first direction. I'll be showing in the slide. So this is my CMM machine, advanced CMM machine, and you can see the probe here, and the carriage will be inside this block. So the carriage how it is provided is like this. One wheel will be provided over this for the motion of this probe. So if I am having the carriage in y direction as well as in x direction, so a motor is provided in x direction which can assist the motion of this wheel in between x and y direction in this way, like in straight line. Okay, understood? So each axis is fitted with a precision measuring system which continuously records the displacement of the carriage from a fixed reference. The third axis carries a probe, that was the Z axis carries a probe. When the probe makes contact with the workpiece, the computer captures the displacement of all the three axes, right? So now coming to the different structures based upon the geometry, the CMM are divided into 5 structures. According to your application, according to your application budget, you can decide which structure you need. So among them, the first one is an cantilever type. So in this cantilever type, the vertical position probe is carried by an cantilever arm. So this is my cantilever arm. This vertical position is controlled. The probe moves up and down along the Z axis. The cantilever arm, so this arm is moved in and out along the y axis. This is the lateral movement, and the longitudinal movement is controlled by the table, which is basically the work table. So the configuration provides easy access to the work pieces, which are basically large. So if you are placing a large work pieces or job over this CMM machine, and you can measure the surface texture of particular job. So now coming to the bridge type, the bridge type configuration is good if better rigidity. If you want the workpiece should be rigid, and after placing rigidly and you just want to measure the surface texture over it, then you can choose this bridge type. The probe unit is mounted on the horizontal moving bridge. So the entire probe unit is fixed over the horizontal moving bed whose support rests on this machine table. So this is the Z axis, and this is my x axis, and this is my y axis. So now coming to the column type, this configuration provides exceptional rigidity and accuracy. Wherever if the workpiece requires much rigidity and accuracy, then we'll be preferring the column type. These type of machines, you'll be calling it as an universal measuring machines. If you just see an universal milling or drilling machine, it will be looking the similar way, and it is quite similar to a boring machine. If you just see an drilling holes for the earth for extraction of the water, those machines will also look similar. Right, now coming to the horizontal arm. So this can also be called as a moving ram horizontal arm type. So here the horizontal movement is given for the probe, and there is a motor attached which can also work vertically also. So if my job or a workpiece is very large in area, then we will be preferring these type of machines. Now coming to the gantry, in this configuration the support of the workpiece is independent of x and y axis. If you just see, there are 4 columns, 1, 2, 3 and 4 columns are attached over this, and the x and y are independent. So the carriage for the x and y are independent for this gantry type, and these type of CMM machines are used generally for the workpieces which are heavy, large to heavy, and whose measurements are independent of the coordinates. There will be using these, and in some of the CMM there might be an installation of the rounded tables also, so that spinning action can also be happen for the workpiece. And for every coordinate system, XYZ systems, there will be a limiter available in the CMM machines. We'll be calling it as an uh, axis limiter, and if my measurement is if whatever the measurement I need is, if I need an precise measurement, then you can install the laser interferometer. That's all guys. So tomorrow I'll be proceeding with the working. Thank you.